So thank you for coming. This session is about a couple of interesting topics, and it's divided into two sections. The first one will be service discovery and security and configuration management. The second one will be more about optimization for cost and performance for your serverless application. So it's not in the title. I hope you will appreciate it. Anyway, let me get some numbers and statistics. How many of you are a developer? Who identifies as a developer? Okay, who comes from the ops world? Okay, who is in the middle? DevOps, like in the heart. Good, nice. So I'm a developer, sorry. Kidding. I started as a developer. I've been working in a startup for more than 4.5 years. I've joined AWS last year as a technical evangelist, which just means I'm still a developer, but I also travel a lot. And I speak often. I still consider myself a software engineer, web developer. So that's the agenda for today. We start with serverless discovery, security, and configuration management. I want to show you some live stuff. I've seen some demos today, but I like to do live coding and live demo. And then we'll talk for the second half about cost optimization. I hope you care about optimizing for cost. And the best thing about optimizing for performance in serverless is that you optimize at the same time for cost and performance. Because if you can run faster, your application will be cheaper. Because in serverless, you are charged based on the execution time of your functions. You don't pay it by the hour, you don't pay it by the month. Okay? If nothing is happening in your system, you scale down to 0. That's a good benefit of serverless. So how many are already using serverless computing? For work, for fun, not too many. Okay, so today I'll be mostly talking about, I think some of the practices and ideas I'll give you are valid out of AWS as well, but I'll be referencing a lot our AWS offering, AWS Lambda. How many people know Lambda already? You have heard of it at least? Good. So Lambda is our function as a service. You can consider function as a service as a layer on top of your, there are instances and then containers, and then there is like this function as a service thing where all your unit of delivery, your unit of deployment is a function. It's not a container, it's not a web server. It's a small function that does something. And you can consider this function as like small microservices that do one thing really, really well. And we take care of the scaling for you. That's really the super high level logic. So why is security, why configuration management? Because every new technologies have to face the same problems over and over, and security and how you configure this stuff is usually the first problems people face, developers face. So let's get into some of the best practices, some of the very bad practices that we keep doing as a developer. That's the main problem, right? We are doing DevOps in the first place. So let me remind you a little bit about the permission model of AWS Lambda. This holds for many other functions as a service as well. So don't be strict about AWS. This totally applies to others. Usually you have very fine-grained security control over your function. So every function as a goal might be reading from a database or writing into a queue or reading from a queue. And as you probably know, you want to apply the least privilege approach. So every function or every container or every instance, depending on which layer you're using, you want it to have only the permission it needs. If it needs to write from the database but not read, okay, just give it write permissions, or the opposite, right? With Lambda, this is pretty easy. You have two concepts, the execution policies, and these, as the example states, specify what your functions can do. Okay, your function A can read from a database, but not write, and only from a specific table. Okay, very fine-grained control over permissions. Actually, if you're using DynamoDB, this is interesting in my opinion, you can even pin it down to even more granular. You can say, can you read from the users table only this column? Okay, very, very granular permissions. And then there is another concept of function policy, and this is the complementary, okay? Who can invoke your functions? So for example, if you want to run your functions when an event is happening, that's another big advantage of serverless being event-driven, not process or, you talk about events. Your functions are triggered, executed when something happens. If nothing happens, you pay 0. So you still want to have very granular control about who can invoke your function. So if you want your function to be executed when there is a new object on your S3 buckets, for example, our object storage, or when there is a new record inserted into your DynamoDB tables, for example, you want to run some code, and you need to specify exactly, okay, S3 can invoke this specific Lambda function. So full security control about who does what and why. Then, permissions. This is the typical initial approach. Okay, my function can do S3 star, or DynamoDB star, or SNS star. Okay, this makes all the puppies in the world cry. Don't do that. You're probably aware of that, but this is what most developers will start from, because I'm working in my local environment. It's my small account with 0 monthly spent, so there is no risk of breaking anything. But then you have to deploy this stuff to production. And what happens is that you spend more hours fixing your permission, these IAM permissions, than it took you to write the actual microservice. So if you're a developer, remember, if you're not a developer, tell your developers to learn how to use AWS IAM and write their IAM permissions as the first thing. Your functions need to read from Dynamo, give it Dynamo, get item permission. That's it. It's one line of code in your templates. Because why is this wrong? Because DynamoDB star means that function can create tables, destroy tables, update tables, changing the capacity of those tables. Like it can do very bad stuff. Same for SNS, S3, and so on. So don't do that. There are better ways to do it, of course. And if you're using CloudFormation, or if you're using other tools like Terraform, you can probably do this with 3 or 4 lines of code. That's how you do it for DynamoDB.getItem. You can say just allow this operation, get item, only on this specific table. You can get deeper if you want, but this is the minimum I would recommend, okay? So it's not 2 hours of additional development. It's 4 lines of code, and you can even parameterize this stuff. And there are ready-to-use policies that you can just parameterize. There is a second really, really bad thing that developers like doing, which is making things work really fast. And in order to do it, they are code stuff around. It could be a host name, it could be an API endpoint, it could be a token or a secret or a password. So this is also really bad. So we don't want to make fish cry, right? So how do you deal with this issue, this challenge, let's say? Every computing platform has more or less the same solutions, and I'll showcase them for you. The first approach will be using environment variables. Okay, super trivial. If you're using a terminal, you exactly know what an environment variable is. You have the same concept with Lambda functions. So you just inject an environment variables, and you use it, or you change the internal logics based on the value of that. It could be a debug, true, false. It could be a feature flag. It could be an API endpoint that's dependent on the environment. So this is intuitively key value pairs that you just inject into your function. So nothing really changes, just a dynamic value. Well, in Lambda, you can just read your environment functions using the runtime operating system API. Okay, if you're developing in Python or Java or JavaScript or .NET or whatever other language that you're using on Lambda, you can use all of them. By the way, you can even bring your custom runtime now. You just do like proc.env or os environ, like exactly the typical environment variable API from your programming language. So if you already have something reading up environment variables running on EC2 and you move it to Lambda, nothing really changes in your code. You keep injecting the same environment variables. You can encrypt them. And this is a good fit, in my opinion, not for everything. I wouldn't use this for a secret, a password, a token, something that needs to change every now and then. I would use this for stuff that changes based on the environment. For example, if we have a dev environment, a test environment, a prod environment, maybe there are some values in your code that need to change, like the host name of the API or the name of a parameter that you're reading from an external service. So you can use Lambda environment variables just for that. And it's fairly easy to use. I'll show an example later. But sometimes you have, I don't know, 25 functions that need to use the same parameter. And what happens when the parameter changes? What do you go and update, redeploy 25 functions? It's not ideal. And this is the same problem with instances and containers as well. There is a better way to do it. For example, on AWS, you have a service called System Manager Parameter Store. And by the way, it's a free service, so there is no real reason why you shouldn't be using it already. And it really helps you centralize the storage of your parameters. Parameters can be anything. Okay, so it could be a secret, it could be a password, a user, a host name, anything centralized. So all your function will spin up and go and read from the parameter store and fetch the value at execution time. Why not? All the benefits, it's hierarchical. This is interesting, because maybe you have 10 parameters that your function needs. You don't have to do 10 API calls, okay? That would be time-consuming and not super efficient. What you want to do is to say, hey, give me all the /app/dev parameters, because this is the dev function, and give me everything below this prefix. So you will fetch maybe 10 or 20 parameters with one API call. So, you know, it supports hierarchies. I think it's a good feature to have. And this is good for stuff like centralized environment variables, or maybe secrets, or maybe feature flags. So a function startups and fetches if it's a debug mode or not, or fetches if this new feature is enabled for the current user or not. So you can use it to centralize logic. And you have a nice UI, so you go there, update the value, save, and you have the history of the parameters values, and, you know, of course you have granular controls about who can write, who can read those parameters, and who can change them, who can create new ones. So you can be super granular with your security permissions. How do you do this with code? Enough theory. So this is in Python. How many here can proficiently read Python? All the others will be able to at the end of the presentation. Don't worry. So here I'm using Boto 3. That's the official AWS SDK for Python. And I'm reading the, I'm creating an SSM object. That's the client for the system manager service. And I'm just doing ssm.getParameter, give it a name, optionally tell it if you want to decrypt the parameter before it returns it to you. And that's it, okay? It's 4 lines of code. You can do it at runtime. You can do it in the function warm-up, initialization part. That's up to you. I've actually written a library. It's a Python library, but the same logic might be re-implemented in Go or other languages too. It's called SSM cache. So it gives you some caching, grouping, syntactic sugar to handle your parameters on Lambda. So for example, you just define your SSM parameter, give it a name, param.value. It's a bit easier, I think, and then you have a lot of more features like caching and grouping of multiple parameters and so on. It's on GitHub if you want, check it out. Sometimes though, you have something more complex or sophisticated than just a feature flag or an environment variable. You have secrets, okay? They are another beast, okay? They have other issues, they have challenges. For example, secrets, you may want to rotate them and change them as often as possible, because they are very sensitive information, like the password of a database or a token of a third-party API. You don't want it to be out there for months or years. Maybe you want to rotate it every month or every week or every day, right? So we have this other service called Secrets Manager. This is not free, like the parameter store, but it gives you more feature when you want to rotate and retrieve and handle the life cycle of your secrets without breaking stuff. That should be highlighted. Of course, it keeps track of different passwords and secret versions, and it's also built in, it's integrated built-in with your databases on AWS. So if you're using Amazon RDS with MySQL, Postgres, and all the other MariaDB and all the other supported databases, you can just say, hey, use this secret management secret for the database and change it every day. done, okay? It will integrate it, will update the password, and all your clients will use the Secrets Manager API to retrieve the current password, okay? So you really don't have to deal with all this complexity. And then a lot of customers told us, but I want to use both the Secrets Manager and the parameter store. Can you make it simpler so I don't have to use 2 clients, 2 APIs, 2 different syntax? So we built something that is uniform. So now you can use the parameter store API to retrieve secrets as well. You just give it a prefix, okay? If you use that prefix, AWS reference secrets manager, and then you use your secrets name, you can use the parameter store API. It is not crazy, but for a lot of customers, it makes it easier to use both services at the same time with a uniform interface. So that's how you use it. Another little bit of Python code. So all you need is this prefix up here. And when you call the get parameter API, you prefix your secret name with the prefix, and it works. If you like to simplify stuff like I do, I created the same in the library I've mentioned. So you can define a new secrets manager parameter, give it a name, and then you have the same syntax. So the library takes care of prefixing, validating, caching, and so on. OK, demo. Let's see how it looks like for real in the real world. So there is a link, and this is a link that I would encourage everyone to check out, because it's a workshop. It's something really fancy on GitHub. It's a self-paced workshop that everybody can take, everybody can go through. It will teach you a lot if you are into serverless and if you want to improve the security posture of your serverless applications. I didn't build it, my colleagues built it, but it's super good. So there are a lot of modules here, and each module will tell you something about a specific area of security, and they are actually mapped to the top 10 OWASP stuff. So there is a module about authentication, one about secret, input validation, encryption, web application firewall, X-Ray for tracing and correlating IDs and stuff like that. So today we're talking about secrets, so I will show you what the secrets module looks like. So let me see what I have here. So, okay, the context in which the workshop is working is we have a unicorn rental service, like Uber for unicorns. Okay, it's just a stupid context, just to play with it. And so we are building like some secure APIs to customize your unicorns. Just don't think about unicorns for a second, if you can. But it's simple enough to understand. So we have an API that I can show you. So I already deployed it. I have a dev environment, and I have a socks API to customize the socks or the hats or the different parts of your unicorns. So I can invoke it. It will just give me the list of socks or customizations, whatever it is. As you can see, it's taking a while because the function is running inside a VPC. There is some cold start initialization for the VPC to work. But then, it works. And if I keep invoking it, it takes like 100 milliseconds. It's pretty fast. But here, let me show you what the code looks like. So I have the Lambda handler. The Lambda handler is just a Node.js function, nothing crazy. You have an event, incoming event, some context, a callback, if you want to invoke when you're done. So this is doing nothing crazy, just let me show you it a bit bigger. Can I go full screen? Maybe. So what's happening is just based on the store, on the resource, the same Lambda function is invoked for the different parts. So /horns, /socks, /glasses, they are all invoking the same function. That's, depend up to you. And then based on the body part, if there is nothing, it's a 400 error. If there is something, it's calling this dbutil list body part options. So let me get there. So what this function is doing, it's select everything from body part, and body part is the input. So this is already bad enough, but the workshop is designed to tell you how to deal with security and injection and web application firewall. So this is the starting point. This is not the final code that you'll be writing. But if we dive deeper into the execute DB query function, so first of all, it's creating a connection, and to create a connection, it's getting the DB config. And you have an idea already of what's in there. Hard-coded user and password, of course. That's the starting point. And even the host is hard-coded up here somewhere. This is the host, okay? This is the host name of the cluster of my MySQL RDS database. So I want to improve that. I don't want to hard-code host name, username, and password. By the way, the password is also very secure, as you can see. So how do we improve that? First of all, we open the secrets manager, and let me guide you through the process. So there are different options for DocumentDB, for Redshift. Now we are using RDS, so I'm going forward with RDS. Our username is admin, the password is this one. Let me paste it, okay. Encryption keys, you can bring your own if you want. I select which cluster I want the security, the secret rotation to work with. And then we proceed, we give it a name. It could be something like Kyiv demo secret. Just give it a fancy description and go on. Okay, here you can configure the real important stuff. So do you want to enable automatic rotation? If we want, because we don't want to do it ourselves, we want to automate stuff, right? So enable rotation, you select how many days, every month, every 2 months. I like to do it every day because why not? It's automatic. And one function execution every day is pretty much free, so why not every day? And I can even use my own custom Lambda function to handle the lifecycle. So if I'm rotating and I want to update some third-party service, maybe I have a Twitter token that I need to call the Twitter API to get a new one. You can customize the flow. For RDS, we don't need to do anything custom because it's built in. You just give it a random name, Lambda secret function name. And then you can say, yeah, just use this secret. It's fine. So we called it, yeah, next. So this is just the review phase, and we say store it. But even before you create it, you are given all the code that you can use for JavaScript, for C#, for Python, Ruby, Go. So just you can copy that snippet and use it in your code. You don't need to learn a lot of APIs or learn a lot of SDK complexity. So just store it. And I think if I did it correctly, I already told it to start rotating it right now. Okay, so in like a minute or something, the password will change. And the same, if I don't update my code as well, the query will fail because I'm using the old password, right? So let's go and update the code in the meantime. So I have a better version of that function. So first of all, we need to use the SDK, create the secrets manager, and I am using an environment variable to store the name of the secret, okay? Because that might be different based on the environment. I might have a password for development, a password for production. So I'd better store a different secret name in the environment variable. And then I already, let's comment this one here. It's really bad implementation. And I have a better implementation here. Sorry, this would be too much to live code for me, too much JavaScript on stage. So all this new getDB config is doing is using the secrets client to get the secret value using the secret name, nothing crazy. If there is an error, okay, something went wrong. If everything went fine, just parse it, because in that secret we have now the host, the username, and the password of the database. So every time the password gets updated, it will fetch it again, and you will have the new updated value. That's it. Nothing else to change in your code. Let's see if the password secret, if the secret is working. So if I invoke again this endpoint, Now I get an error, okay? Because the code is using the old password, of course. So let's deploy. Here I'm using the AWS CLI to package my code together to create an artifact. And then I'm using CloudFormation deploy to deploy everything using CloudFormation. So this will probably take another 30 seconds or something. And what will happen is the same API will now fetch at runtime the secret and do the query, and the query works. Another interesting thing about the secrets is that you can change the rotation configuration. You can, if you have enough permissions, you can go here and retrieve the value. So the current value for the password looks much better. Yes, better. And it will change every day from now on. So I feel safer, let's say. And if anything goes wrong, and maybe you are changing your secret every 2 weeks, but it gets leaked or you have some security problem, you can just, with one click or with that one API call, just rotate it immediately. Okay, so whoever using the password, that's not valid anymore, and your functions, your code, will automatically start fetching the new password in a second. Let's see the deployment completed, and I can reload the API, and it's still failing. Awesome. So I did something wrong, but I'm a developer. That happens. Let me figure it out real quick. Oh yeah, I did not update the secret value. That's something I didn't do. So the name of my secret is this one here. And when I deployed my function, I should have updated this secret name. This is an environment variable. And of course, if you don't update it, it doesn't work. So that's the environment variable. There is something else you need to do, and this is important, is you need to give the function permissions to read the secret. Because by default, it will not have permission to read a secret, of course. So you can do so in like 5 lines of code. Okay, this is how you do it. Allow statement, secrets manager gets secret value. Here, you should be better. I'm already doing the same error. Here, you should provide permission only to that specific secret, not all of them. Okay, so the best practice would be do not create the secret in a console like I did. Create the secret in your infrastructure as code template and reference the secret, okay? But it's a live demo, so it's boring if I do it with YAML. And YAML isn't code, as we all agreed this morning. So if you redeploy, it works. I hope you trust me, so we can move forward. But if you don't, I will deploy again real quick. Any question on this? Because then I'm changing topic. Yes?
Will these secrets automatically apply to the RDS database itself?
What do you mean?
I mean, once you change it, or secret manager changes the credentials itself,
yeah.
will be automatically applied to database.
Absolutely, that's the magic. Yeah. So the point is there is a built-in integration between secrets manager and RDS, so that every time there is a rotation via API with a click or with a scheduled rotation, you're good. What needs to change is so all the connections that are open will stop working. So another thing you will need to change in your code is handle the invalid credential error and refetch the secret on error if it gives you a password invalid. Exactly. You need to be resilient to that, and you need to plan for it. So when the query fails and it's a password error, refetch the secret is probably that. But if you're using my Python library, I can't use it with Node, but in my Python library, that's also built in. So you just give it, listen for this exception. When there is this exception, just refetch the secret, and you're good. The deployment succeeded. Still, sorry guys, I'm doing something else wrong. No, now it works. It was just the same runtime. Okay, so I'm now fetching the database. The query is right, and I'm using the new secret. In 24 hours, I'll meet you tomorrow here at the same time. We make sure it's updating again. Cool. If you want to check out the full workshop, this is just one module. Check it out. It's really good, really well written. Any other question about this topic? Cool. Second topic is optimization techniques for performance and cost. So these are two very correlated aspects of serverless, because as I mentioned at the beginning of the session, when you make your function run faster, you can actually make it cheaper. You are charged on a 100 millisecond interval. Okay, so if you run for 180 milliseconds, you are charged for 200. If you go 210, you're charged 300. Okay, so sometimes you make your function run 20 milliseconds faster, you can pay half. Okay, or 2/3, depending on how much. If you're running 120 and you make it 20 milliseconds faster, you will pay only 100. So you can, with small performance optimization, you can drastically reduce the cost. So it's really important, first of all, to understand which functions you can optimize in this way and how. So I hope this second part helps you with that. So this is the anatomy of your functions. There is something that we handle and something that you provide. The little dot in the center is what you provide. That's your function, your code. Everything around it, the runtime, the environment, the container. It's not actually a container, it's a micro virtual machine. But we can talk about it today. If you have questions about how it works, I can take questions later. And all the huge compute cluster, that's all handled by us. You just provide your function. And in the life cycle of a request, there are certain things that need to happen. So the first 3 steps are what we call a cold start, okay? Because this stuff happens after a while that you haven't invoked your function. We need to initialize some stuff. And then we can start your code. And this is what we call a warm start, okay? If your function is already initialized and warm, all we need to do is just run your code again. Okay, and there are certain things that we optimize for you, and we do it every day. We want the cold start to be as short as possible. And there are other things that you can optimize on the right-hand side. And here we're talking about mostly your code, but since a few months ago, you can even bring your own runtime. So the community and the partners are building runtimes for like PHP and COBOL and Fortran and C++. Every runtime that we do not support natively, you can bring your own. So in a way now, if you're bringing your own runtime, you can also optimize your runtime. But most of the built-in ones, we take care of it as well. Of course, you get the same view about cold starts, warm starts, execution time if you're using something like X-Ray, or if you're using some external third-party tools like, I don't know, Datadog or Hexagon, or there are like hundreds of them now. But let me get into the how do you make your code faster and cheaper. So efficient code, the first suggestion is try to avoid what we call this monolithic function, these fat functions that do everything you need to do in one big function. This is bad for a few reasons. It's appealing because if you have like an Express.js application or a Django or a Flask application, you just want to lift and shift that application without touching the code to Lambda. And that is possible. But what you end up with is a very fat, big, monolithic function, maybe like 20 megabytes of stuff. Okay, you can imagine how things work under the hood. The bigger is the object, the zip artifact that we upload, the more data we need to move around. Okay, so the smaller and lighter is your artifact, the better we can make it faster. And the biggest impact of this is your dependencies. Okay, especially if you're using Node.js and you have 2,500 million Node modules in your application, you can probably shrink it down. So using full stack web frameworks, like as a web developer, I'm used to Flask and Django and Express. And okay, this is probably not the best solution because they have 200, like out of the 200 features, you are using 5 and you're still uploading 20 megabytes of dependencies. So using like micro frameworks, using something lighter. And actually, if you're doing one thing really well in your function and nothing else, 90% of the times, you don't need really any dependency. That depends on the language. Python or Node or Java, that's kind of language dependent too. And in some languages, you can even optimize the final code for production. So if you're using Webpack or Browserify or some minification step with your Node.js functions, for example, that can speed up a lot. And I have some data points later in the presentation. We're talking 100 odd milliseconds. And 100 milliseconds, if your function is running for 200, it means you can halve your cost just by minifying sometimes. Okay, for Java and Python, this doesn't count, but JavaScript is probably the most well-used code runtime on Lambda. So also remember that your execution environment is ephemeral. Okay, try not to rely too much on local file system, on local memory. Your function will take one event at a time. Even if you're using Node and you have async await stuff, 2 events come, we spin up 2 environments, we spin up 2 runtimes, 2 micro VMs under the hood. So there are some things that you can do to optimize this stuff. One is try to do some lazy loading. So a lot of developers have like 2 or 3 function handlers in the same file. And maybe at the top of the file, you have all your static initialization. Okay, you are doing like initialization for 3 different handlers. So all of them are experiencing 3 times as much cold start than they should. Probably. And you can either split the file or do what we call lazy initialization. Let me show you what it looks like. So maybe you have 2 functions, 2 handlers in the same file, and one function is using a S3 client, another function is using a Dynamo client, DynamoDB client. So what you can do is just define them as none or null or some other weird name, depending on the language, and then you just initialize it at runtime. Okay, this doesn't have a huge impact for the both 3 Python clients, but for other heavier initialization tasks, this might have a big impact. If you are separating the handlers 1 per file, that already makes it better. This comes from a recent post from a friend of mine, Young Kui. So he did an experiment using Node, finding a way to optimize Node dependencies based on the actual usage. So, for example, instead of requiring the full AWS SDK here, if all you need is Dynamo, you can just require the Dynamo client. And you think, what's the difference? I'm just writing more code. But just this, without any other optimization, can give you 125 milliseconds savings. Okay, this means up to 50 or more % of your current execution time, depending on what you're doing with Dynamo. He did a similar experiment with X-Ray. So in X-Ray, you can either require the full X-Ray SDK or maybe only the core, depending on what you need to trace. If you're tracing SDK, API invocations, if you're tracing HTTP invocations or whatever else. So this is not too much, but still 5, 6 milliseconds on average. And if you are running like for 102 milliseconds and you do that, you're spending half with 1 line of code. So this is cool. If you actually do both, so you require only the Dynamo client and you tell X-Ray to only trace DynamoDB, you can save up to 140 milliseconds just by changing the require statement. Okay, I think this is a bit crazy, and there is certainly something we can do to help you with that. But this is like 2 weeks old statistics, and I'm sure we'll be working on it in the future. But this is good to know, in my opinion. If you use even Webpack and you compress all of this, because it's Node.js with Webpack, you save even more, like up to twice as much. So do it. I think my clicker stopped working. Let me go back. Yes. Okay, so there is an article where you find all the statistics and the code and the experiments if you're curious. Here I'm just reporting some of the results, but he also did more experiments that didn't lead to anything interesting. This is the interesting stuff. And his alias is the Burning Monk. Super cool. He's an AWS serverless hero, by the way. Another tip that I like giving to developers is to make their function logic very concise. Okay, build your function handlers to transform data. I think something is going on. Yeah. So use your handlers to transform data, not to transport and to move data around. These are two different tips, actually. So let's start with the Lambda handler. Okay, that should be the smallest logic possible. Everything that is your business logic should be somewhere else. Let me give you an example. I implement something in my class, Python class, could be a Node.js, Java, .NET class. That's my core logic. And in my Lambda handler, all I do is import it. Then your Lambda handler could be as simple as initializing that object, checking if I need to do this, and then you do this, or if you need to do that, and then you do that. And if there's an error, do maybe some error handling and some validation of the input. Okay, that's like the minimal function handler implementation. All your business logic should be somewhere else. For example, in another file with your mylib class, where you initialize clients and constants and secrets and all your stuff. Why is this useful? First of all, because it's more debuggable. Second of all, because you can reuse your business logic on containers, on instances, on another provider, wherever you want. A lot of people are concerned about lock-in. Okay, if you implement your stuff like this, you're not bound to Lambda. Lambda is 10 lines of code. Your business logic is somewhere else. Okay, so think differently, organize your code differently, and you save a lot of problems later. Another example, this is about try to use functions to transform data and not to transport and to download a lot of data. So this is an example doing MapReduce with Lambda. So all it's doing is iterating over a list of keys to download from S3. And then it's reading the body. For each line, it's fetching basically the first 8 characters of each record. Because maybe it was like an IP address or something. It was reading the first part of the address. But maybe each object is 1 megabyte, 2 megabytes. Okay, so we are downloading and waiting for the whole file to be downloaded just to take the first 8 characters. That took about 200 seconds. It was like a long list of objects. Costed about 11 cents of a dollar. If you are using something like S3 Select, Amazon S3 Select is a new feature of S3 that allows you to give it like a SQL, an SQL query, and S3 will just return the data that you want, not the whole object. So by using S3 Select with this kind of syntax, so you, instead of get object, you do select object content, and you give it an SQL statement, like select this from that. So if you do that, I'm only selecting the first 8 characters, and then I'm reading the whole thing, because there is no sub-selection to do. So this is twice as fast, and it costs 1/4 or 1/5 of the cost. Okay, so small changes can lead to huge savings, and this is the key message here. So try to externalize data movement, try to do transformation and to optimize what you actually fetch from your functions, because you are paying for the data transfer waiting time, not for the transfer cost itself. But you are charged for the execution time. So if you can minimize that, it's a lot faster and cheaper. Another tricky point, another challenge that some developers fall into is thinking that, okay, this simple cron job needs to be super cheaper, okay? It's not critical, I don't care about it, just make it as cheap as possible. So I will select the cheapest memory allocation. In Lambda, you basically have this memory handler from 128 megabyte up to 3 gigabytes. Okay, a lot of developers forget that with that memory comes also CPU and networking. It's like, I call it power, usually. It's not just memory, it's a power handler. Okay, it simplifies, but a lot of people think, I want it to be cheap, I just select the cheapest, because that's what we're used to in the instances or in the containers world. In serverless, it's not like that. if you can have the same code with twice as much memory or power, it will probably run twice as faster. So you're paying the same. Okay, you can be faster and cheaper at the same time. So that's a mental performance switch that you need to understand. Let me give you an example. So I have this Lambda function running for 1,000 times all the prime numbers below 1,000,000. So this is a very compute intensive. There's no memory, there is, well, some memory, but there is no networking, there is no I/O, there is nothing really, it's just computation. So if I run it with 128 megabytes, it will run for 11 seconds, and I will pay roughly 2 cents of a dollar, 2.46. Okay, if I run it with twice as much, it'll be almost twice as faster, and I'll pay a little bit more. Okay, if I keep doing it, if I run it with 124 megabytes, so a gigabyte of RAM, it will be 10 times faster because I'm using 10 times much more power. But the cost, look at it. It's not that different. It's 0.001 of a cent of a dollar. So it's kind of the same cost in my opinion. And you're running 10 times faster. So don't think less power means cheaper. Very often, more power means faster and the same or even cheaper, depending if it's a compute intensive, network intensive, or other stuff. Actually, you don't have to guess. I've built a project like already a couple of years ago that I called it Lambda Power Tuning, because I started calling it Power myself. And what it does is it takes your function as input and it will run it with multiple memory configuration. It will fetch the data, the logs. You run it enough times to be statistically relevant. And then at some point in the last steps, you clean it up and you can look at the logs and see which one is better, is cheaper, or is more performant. I've seen some customers using this project as part of their CI/CD automation. So you deploy a new version of the code, you run this, you find the optimal memory configuration, and then you deploy with that configuration. So I think it's a good data-driven way of optimizing your functions. You don't have to guesstimate or randomly estimate or use always the same value. Another final tip, actually two, is don't do orchestration in your code. If you're something like start a job, and then wait for 10 seconds, and then check if the job is done. Okay, those 10 seconds, you're paying for it. You don't want to pay for those 10 seconds on Lambda, because you're charged by the execution time. So something you can do is using the same approach. So this is the same chart I've shown you. This is a state machine implemented with AWS step functions. It's another service on top of Lambda. So you can do something like state machine where the orchestration, the overall logic, is a state machine. So submit a job, get the status, check if it's over. If not, wait 30 seconds and go back. But those 30 seconds, you're not paying for it. Okay? You can wait from 1 second up to a year without paying for that execution time. Step function charges you based on the number of state transitions. So if we have a simple state like start, wait an hour, run this, wait an hour, finish, you're just paying 3 or 4 transitions there. Okay? The waiting time is included in the service. Another tip I can give you is understand who is actually invoking your functions or your APIs. Most of the time you have an API. So if you have a single custom client, you don't really need to have an API gateway in front of it. You might just using the Lambda API. There is a invoke function API that you can use. You don't really need to put an API in front of it. There is already an AWS API for it. If you have an API, if you really need an API, but it's not customer-facing or end-user-facing, you might want to use a regional API gateway endpoint. Those are cheaper and optimized for a specific region. So you can invoke it from within the region, and you don't go out to the internet. So you can optimize for that. And you can even optimize for making sure that you discard events that you don't care about at the source of the event, not inside your code. So maybe your function are executed when there is a new object on S3, but then inside your code you're saying, If it's a JPEG image, okay, I want to process it. If it's not, I don't want to do anything. You can do that at the S3 level so that your function isn't invoked at all unless it's a JPEG image. Okay, you will spare a lot of invocations if your bucket is full of other objects. The same for SNS, for example. One last, actually, let me skip the retry policy. We are out of time, right? So you have concurrency controls to control how many concurrent executions of your Lambda you can allow. Eventually, you can use the same feature to scale down to 0. Okay, maybe you ended up in an infinite loop, or you are having too many calls, or in your dev environment, something is not working how it's supposed to work. So you can use this feature as a kill switch. Just set the concurrency level to 0. It goes down to 0. If you set it to 100, it doesn't mean we are spinning up 100. That's like a maximum concurrency level that we handle for you. Last point, then I'm done, and we have some time for questions, is do you need a VPC? Do you need to run your function within a virtual private cloud network? So by default, I will tell you no. The default response is no. But actually, if there is a state machine for it. So if you need to access a resource that is in a VPC, like an RDS database, like what we are doing during the demo, you have to be in a VPC, okay? So there is a case where you have to. Most of the time you don't. But in that case, do you also need to access the internet, like other APIs? Okay, if that's the case, put it in a subnet where you also have a NAT to access, with an internet gateway to access the internet. If you don't need to access the internet, just put it in a private subnet with your resource and you're good. Okay, but in general, this is the most frequent common response in my experience. So just go for there too if you really have to read an RDS database or, I don't know, Elasticsearch or Elasticache, like Redis and Memcache, and this kind of VPC resources. And that's all I had for you today. I hope you learned something.
We've got a couple of minutes for questions.
Any question? Yes.
Can you give me some info about this virtual machines, micro virtual machines that you use for Lambda?
Okay. So in November last year at reInvent, we announced and we released an open source library that we call Firecracker, AWS Firecracker. Okay, that's actually developed by some colleagues of mine in Romania, here in Europe. And that's a micro VM technology written in Rust. It's on GitHub. And that's basically what's behind services like AWS Lambda and AWS Fargate for spinning up your containers without really handling the cluster behind it. So it's an open source project. You can check it out. It's optimized for performance, for security, but it's not a container. It's a super tiny micro VM that runs on our bare metal hosts where all the hypervisor is in the hardware. So we can spin up 1,000 of them in the same host in like 100 milliseconds. So it's cool technology. Check it out on GitHub. Any other question?
Okay, thank you. And I have a question about how we can organize authorization logic for Lambda. I mean, we have token-based authorization, and we need to check that token is valid on each request. How we can do it with Lambda?
Okay, so you are using there is also API gateway in your architecture. You have an API? You probably haven't.
For the current moment, we're just thinking about Lambda, so we don't have Lambda at all, and we want to use it, but we need to handle authorization somehow. What is the best option?
My suggestion in that case would be put an API gateway in front of it, and then you can use what we call a Lambda authorizer. This is a bit meta, because you have an API that's invoking your function. You can have another function that's invoked before API gateway forwards the request to your function that decides whether the request is authenticated or not, based on a header, based on other integrations that you might have with Cognito, with your SAML provider, with another third-party identity provider. So that's supported, and under the hood, it's all based on IAM. So this custom Lambda authorizer will return back an IAM role and will give this specific identity a role to invoke or not the function that you're trying to invoke. Make sense?
Yeah, makes sense.
Cool. Thank you everybody for coming. I'm around if you have other questions.